Hello Geometry, this is 12.1 extension notes. You should get the first part of your notes, the vocab, the picture, be able to draw on this picture and fill in this note sheet from the reading. It talks about what a circle is, interior, exterior, the chord, diameter, radius, all of these topics that you can get from the reading, pretty easy stuff. But what I wanted to specifically talk about today were a couple of circle theorems that maybe you haven't seen before. It will talk about in a reading, point of tangency, concentric circles, and you can fill all of this stuff out, and you can find the vocab for this. But there are three tangent theorems that are pretty important that show up in a lot of different places, and I want to make sure that you're just solid on this and maybe a couple example problems that go with it. Okay? First of all, this little guy right here, we have our circle. Let's go to our pen. We have our circle, and we want to look at this little spot right here. And this is a tangent because it hits one, like skips off the circle, and that is a point of tangency right there. And the thing I want you to know is anytime there's a point of tangency, anytime you have that spot, the radius and the point of tangency form a right angle. Okay? So at the point of tangency with the radius, there is a right angle, and we know that's 90 degrees here, right here. Okay? So that's number one. If you have a tangent and you have a radius at the point of tangency, they come together, there's a right angle. Theorem number two is the same thing in reverse. And it says this: if there's a right angle, if angle 1 is 90 degrees, so if that's angle, we'll put an angle 1 here, just put a little 1 right in there. If angle 1 is equal to 90 degrees, then AB is tangent. Really the same piece of information. This one says if tangent and radius then right angle. This one says if right angle then tangent and radius. So it's the exact same thing in different order. But it's really important that you know that there's a right angle there. And then the last one, we have a point and we have two tangents from the same point. From, let's call that point A and this point B and this point C. And the rule here is that if you have an external point and it goes to two spots, these two chunks are congruent. You have an external point that draws two tangents to a circle, A to B should be congruent to A to C. And these theorems and the circle vocab will lead to being able to do the following problems. So let's look at a couple problems here. Okay. Number one is it says is A to B tangent to the circle? It doesn't know. You haven't zoomed in at a microscopic level, and you can't really tell without doing some math. So I have a triangle. It wants to know if that's tangent. Well, if it's tangent, then that should be a right angle, and we have to check for a right angle. So I would do 5 squared plus 14 squared and see if it's equal to 15 squared. If they're equal, then it's a tangent. If they're not equal, it's not a tangent. This is 25 plus 14 squared is 196. And 196 plus 25 is 221. 15 squared is 225. They are not equal. And if they're not equal, it's not a tangent. Not a tangent. There has to be a right angle there in order for it to be a tangent. Okay? Next one says find the radius of the circle. Find the radius of the circle. So here's my R value right here. That's the radius. And we would have to assume here that that is a tangent. In fact, I'm going to write that here. This is a tangent line. Tangent line. Okay, so I'm gonna do the math problem. So I'm gonna go R squared plus 16 squared equals, and a lot of times it'll depend on what they give you. If they gave you this whole thing was 8 or 18 or whatever it was, you could put 18 squared, but this 8 on this problem is referring to that. So when you do the problems, make sure you see is it referring to the whole thing. If so, you can put a number there, but if they just have an 8 there, I'm going to call that 8, and this is another radius. So that whole distance right there is r plus 8 squared. And that would be the setup on this problem. Again, another problem, I think one of the homework quiz problems. I'm just going to set it up here real quick for you. It'll give you something like this where it'll say find the radius, and this is 12, and this is, I don't know, this is 20 or something like that from there to there. And on that one you would go r squared plus 12 squared equals 20 squared. And it's a completely different problem because it's set up differently. So you have to determine, are they giving you that whole distance or are they giving you a chunk? And it should tell you in the problem. I'm going to do this one. This one's pretty easy. You can do that. I'm going to do this one. Okay? It becomes r squared plus 16 squared is 256 equals, well, r plus 8, you have to FOIL. R plus 8 squared is r plus 8 times r plus 8, or r squared, 8r and another 8r, and 64. I FOIL it out. R squared plus 256 equals r squared plus 16r plus 64. The nice part about this problem is the r squareds will cancel each other out when you subtract them over. So I'd subtract the r squareds over and wipe them out. I would then subtract the 64 over. And I get 16r equals, well, 256 minus 64. Somebody let a duck loose in my room. All right, is 192. And I'll divide by 16. My r value is 192 divided by 16. And I got an r value, a radius of 12. Okay. A couple more here, see what else we got. All right, it says find x. AB and AC are tangents. Well, if that's tangent to that, these two distances will be the same. So it's 3x squared minus 9 equals 72. External point, two tangents, those two chunks have to be the same. I'll add 9. I got 3x squared equals 72 plus 9 is 81. I'll divide by 3. I get x squared is 27, and I'll square root it. That's 9 times 3, or 3 radical 3 for my x value. X is 3 radical 3, which you could, you could decimalize that 5 point whatever. Square root of 25 is 5, so 27 is a little over that, so like 5.1 or something like that if you wanted to decimalize it. I would mention this. There's a homework problem that says something like that. See if I can get rid of a little bit of that here. It gives you some answers. It gives you some numbers. Like it tells you this is 3, and maybe this down here is 5, and maybe this right here is 4. And by that I mean that distance from there to there. 5 is the distance from there to there, and 3 is the distance from there to there. And it asks you to find the perimeter of the figure of the triangle. Well, here's the way I would do it. If that's 4, that distance is also 4. If that's 5, that distance is also 5. If that's 3, that distance is also 3. These two are the same, these two are the same, and these two are the same. So 10 and 6 is 16, and 8. The perimeter of this figure would be 24 if you were doing a problem like that. I think I did my math right. This is 9, 5, 7, 8, and 7. Yeah, it's 24. Okay. Those circle theorems also can go on to a set of problems like this where we're on a coordinate plane. Number 1, find the center of A and B. All right, well, the center of A is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The center of A A center is at 5, 5, and B's center is at 5, 10, 15, 20, up 5, B is at 20, 5. Find the radius of A and B. That's super easy. That radius right there is 5. A has a radius of 5. B has a radius that is 10. Describe the intersection of the two circles. Well, the intersection of the two circles, those two circles hit in one spot. They hit in that one spot. And they're outside of each other. The vocab is they are externally tangent to each other. Externally tangent. Find the common internal tangent of the two circles. Common internal tangent is the line that I would draw right like this going between the two circles. That is called a common internal tangent because it hits both circles. 1, 2, it's excited at 5, 10. It's an x equals 10 line. The common internal tangent is x equals 10. And draw both common external tangents. Well, here's a common external tangent. And here's a common external tangent. There's 2 of them. And these are points of tangency. That should help you complete the last part of the chapter. I wanted to show you those extra theorems just because they're the hard part. Good luck.